A fun little integral here in problem 12. And so first, notice that we can write the given integral like this, and there isn't much required to see why this is equal to this, except square root rules in the denominator, right? Okay, and from here, we're going to let square root of x equal t, yeah? And so then that means t is x to the 1/2. And so you know the name of the game from here. We have to figure out what dt is, which is this. And so then we solve for dx, because ultimately we want to substitute for x's in terms of t. And so that means that dx is 2 root x dt, but root x is equal to t, right? And therefore we go dx is 2t dt. Okay, so we come to our integral, and also we got to take care of the limits before we welcome. Yeah, so a fun little integral here. And to start, notice that the given integral can be written like this, right? And there isn't much required to see why this is the same as this here, except for square root rules applied in the denominator. Welcome, a fun little integral here. And to start, notice that the given problem, this can be written like that. And there isn't much required to see why they're equal other than square root rules and the denominator, right? Okay, now moving forward, we're going to make the substitution that root x, this guy here, be equal to t. So then, you know the name of the game, we have to find dt, and dt is going to involve dx. And so we solve for dx, and dx is going to be this. You could do it more carefully if you'd like. But yeah, root x we said is t. So dx is really 2t dt, right? And so with this handy, let's change the limits to be about t also. And then we could rewrite our given integral all in terms of t. Now, 0 here is going to turn into root 0. Okay, that's still 0. And same happens with 1, which is it doesn't change after all, yeah? Okay, because root 1 is the same as 1, right? So our integral then is 0 to 1, and then dx we know is 2t dt, right? And so we write the 2 in front of the integral and just write a t dt, and divided by, we know that root x is t, so we get divided by t. And then if root x is t, then t squared is x, right? So we need a replacement for this x, and that's t squared. That's going to replace the x, right? Okay, so yeah. Yeah, I just wrote that. Okay, I didn't actually. It was pre-recorded. I didn't just write it. Okay. All right. Yeah, I can't believe your eyes. Okay, so, you know, like, good things happen now. Like, this t here is going to cancel that t there, right? And so then what we'll have in the integrand is the derivative of arc sine. So we have 2 times arc sine of t evaluated from 0 to 1. That'll look like that. So plug in 1, plug in 0, take the difference. That's what we do, right? Okay? And now sine inverse of 0 is 0. So this whole thing here is just 0. And sine inverse of 1 is pi over 2. So our final answer is going to be 2 times pi over 2, also known as pi. Yeah? Bye.